Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, string compression 2. So basically this question was asked in Google and Microsoft. So from there only you can take like how much important this question is and the concepts which would be used in this question, those would be as well. So apart from the knowledge of that in which company this was asked, so now let us go ahead by reading this question and then about the constraints and then building up the intuition for doing this particular question. And today we will be going ahead by building up intuition through the dry run of the test cases and then we will be moving ahead that how we are going to code this question. So stay tuned till the end and focus on what I am trying to explain you so that you could get better that what exactly and how this question is about to be solved. So now let us start. So run length encoding. Basically here you can see so it changes the cursor so it will move you to some other page. So basically this is some standard method that's right. So basically, this is a string compression method that works by replacing consecutive identical characters repeated two or more times with the concatenation of character and the number marking the count of the characters, that is length of the run. Here run simply refers to the consecutive characters which are being there. If A is there, then how many number of times A has been there all together means A, four times A is there. So it would be written as A and then 4. So that is what they want to say in this whole line. And to know more about the same, you can click over this particular link and means this is a link and then you will get to know more. But from my experience here, this much is enough for this particular question. So you don't need to explicitly go to that link. Now they have given us example that for example to compress the string A, B, C, we replace two A's by A2 and replace three C's by C3. Thus the compressed string becomes A2BC3. So that's the thing. And now one more thing which is there that notice that in this problem we are not adding one after the single characters. So the thing is that if there are more than one characters, right, then only we will be add a number just after that particular character and that number will indicate that how many times that particular character has been occurred consecutively. So that's the thing. And if that character has occurred just one time, right? So in that scenario, we won't be adding up any number after that character. So that's the thing which we will be doing here. Now comes the next part that given a string s and an integer k. So these two things are given to us. So you need to delete at most k characters. Means at most. That simply means either you can delete a character or you cannot delete a character. Means that it is just at most you can delete k characters, not more than that, and even it is your choice only that do you want to delete a character or not. But the end result should be that what they want key characters from S such that the run length encoded version of S has the minimum length. So basically at the end we require the minimum length of the run and length encoded version of S. So in that context only, either you can delete k characters at most or it's your choice that you want to delete or not delete. But at the end, you should have minimum length of that run length encoded version of it. So that is the thing which they want to say in this particular line. So what they want to say, let me explain you. See, if we take A, C and D, right? So it could be encoded like this in the run length encoded version. Now if K is equal to 2, right? So it is our choice that if we say not 2, hmm, let us take another example. Here let us add E also. So K is equal to 2, right? Um, say, I don't know if they have given an example or not, but see. So if E like this, so here it would be something like this. So at most we can delete two characters, right? So we will be deleting this, so it will become CDE2. Or if we delete CD, then it becomes A2E2, right? So in either of the case, at the end we will be having four lanes only, right? So we delete K exactly by 2, right? If K was something like this, means K was just 1. So in that context, if it is A2, C, D, E2, right? So if we delete this, then also we have 5. If we delete this, then also it is having 5. If we delete one of them, then there would be like A2, C, D, E. Then also it is 5 only. So in all these contexts, it is like that. I just wanted to give you some example in which if we delete or not delete, still there is not much uh, difference. So here at most we can delete one character. Or if we say that k is equal to 0, let us take that only. So if k is equal to 0, that means we can't delete any character, right? So in that context, we will be returning this one only. So here at most 0 characters could be deleted or not deleted. But let us see that, let us see their example only if there is some example like that which I want to explain. No, there is no such example. Basically, I just wanted to explain you that there could be some instances like that also when you are not required to delete any character. The length which is being given to us, like here A, B, C, D, right? And here if you are given with k is equal to 1. So yeah, here if you delete any one of the length, then you will be getting same answer. But if it is something like this, A, B, B, C, yeah, here this is the example. Like A, B, B, C, C, and D, D. And K is equal to 1, right? So even if you delete any one of the character, so here it will become A2, B2, C2, and D2, right? So if you delete any of the character, hmm, let us take A2, then it will become A2, B2, C2, and D2, right? Or if we delete any, hmm, that all won't work. Let us take A4 and B3. Now here, if k equals 2, let us say k equals to 1. So here if you delete one character, then it will become like this, or it could be something like this. So in either of the case, you can see that either we delete or we don't delete, right? Then in all that scenario, our length is already minimum. So here they just want to say that at most you can delete one character, but still our length is remaining same. Either we delete it or we don't delete it, right? So this is the perfect example which I was trying to tell you that at most we can delete one character. That is the thing. But it's also a choice that we don't want to delete it also. So that's the scenario here. Now comes the next part about these examples. So from previous ones also I've already explained a lot. So let us first take the constraints and then we will be going ahead with the final explanation of intuition building. So basically here constraints are till 100, right? So length of this particular will be till 100. So that's why we can go till 10 raised to power 2, that is 10 raised to power 4 solution, that is n square will work, n log n will also work, right? And if we go ahead with 10 raised to power 6, that is n cube solution. Here it could give us some daily sort of situation as well because it will be about 10 raised to power 6, right? So better to go ahead with this n square solution or something like n square into k. That is this s dot length, whatever is there, right? So some solution like this it could be means better than this. We should go ahead with this. So some solutions like this could be built because this length is also there. So the time according to time constraints we can take that we can build up some solution like n square or n into k square, something like that could be built. So that's the scenario here. Now because here you can see clearly, let's see, we are required means we are given with some choices that either we can choose this particular string in, I mean basically this particular character, or we can't choose this character. Only thing is that at the end the result should be something like that it should be minimum length, right? So in that context, either we will be choosing this character or we won't be choosing this character. And in context to that, we are required to check for few more things as well. That is that can we delete or can't we delete? These two things also we are required to check. And even we are required to check that while choosing, we are required to check that now how much count has been there, right? This thing also we are required to check. Means there are four things which we will be checking in this particular question. And those four things will be changing, and according to that only we are required to devise a solution. So that's a thing in this spring question. Now, let us go ahead with the explanation for this thing. So then only we will get to know that how exactly things will be working. So here you can see that our ultimate goal is that we require minimum length, right? So there are two things that either both of means all the characters which are there, they would be same, right? So in that sense, our string length will be directly like this, or because our string length, basically our string size was less than equal to 100 and greater than equal to, I don't know, it was 0 or 1, right? So in this context, there could be like, I'm saying about this. This A could go till 10 also, right? So here, then it will become A10, or here it will also become A100, right? And also it can become A2. So basically, according to these scenarios, the string length is varying, right? Here you can see the string length is 2. Here you can see string length is 3. And here you can see string length is 4. So this is in that scenario when all the characters are same, right? But when all the characters are different, then in that scenario, it will be directly whatever length is there. So here also this scenario will come into picture, but that would be in context of that how many words are basically there. But the thing is that here minimum it got to 4, right? But here minimum it won't go to 4. It can go up to 100 as well, right? If all the characters are different, means basically if there is something like this, means A to Z all characters are there 26, then again it starts from A to Z. Then again 26, then again it starts from A to Z, then again 26. Here the things would be that all the characters are different when they are consecutive in nature. Means a, B, these are the two consecutive, right? And both of them are different, right? So that's the 26, 26, 26 up till 100. So because the max length could be 100, so here the final answer will be up till 100, right? So in this, we can't minimize when all the things are different. So in that context, we will be taking the character as it is. But we can minimize the character in this context, right? In this context, how we can minimize? According to our k value, right? So here, from here only got to know that here we are required to check that what was a previous character and what is the count of that particular character if that previous character has occurred again. So that we got to know. And if there is no previous character which is basically equal to present character, then what we are required to do and how we are required to increase our count. So that thing we got to know from this particular, right? So now let us take our first example only where K was also given, right? So here I was just explaining that what cases could be there. So here the K is also there. Now in this case, A3, then B as it is, because when it is a one character, then we won't be appending that uh, length of that. Basically, that how many times that character has occurred, that won't be appended, right? So that's why we are taking B as it is. Then C occurs 3 times, so that's why C3, and then D as it is. So in this, and then our length would be 6. So that is what we are doing. Then A occurs here. You can see that we can delete 2 characters, right? So I deleted 2 A's here. So it becomes ABC, right? And C occurs 3 times, so that's why D. So here I deleted B and 2, I've deleted 1B and 1C. So that's why it becomes A3, C2 and D. Then again, it is just 5. Then here I take A3, B, C, D. Right here I deleted 2C's. Right. So again it is 5. But here when I deleted these 2 B and C. Right. So now it becomes 4 length. So like this only we are required to check. Means earlier what I was telling you that when they are only A's, right? So in that context we can deduct from them so that it can't reach up to 10 or 100. In that context I was saying. But that will be directly a greedy approach, right? And that greedy approach sometimes can't work the way in this first example it was not working, right? So in that context, we are required to check for each position. That at each position, after deleting this particular character, what length we are getting overall. So in that context only, this whole question becomes inclusion and exclusion question of DP. So that was the thing here. And this is, I just wanted to get you to the point that here, rather than going ahead with a greedy approach, here we are required to check for each sub problem and how with each sub problem we are able to get the minimum length. So the thing is that include and exclude at each point to know whether this is minimum possibility or not. So that is the whole context of this question which we are required to do. With the things that here these four variables would be required as per the question requirement. See, first would be index, that at what index that particular character is. And then second would be previous character. Why we require previous character? Because see, if you don't know that what was the previous character, then how we will count that was that again repeated or was that a new character which is now there at the present position, right? So that's why we require with this previous character. Okay. So now comes the next part about the count of the character. So when we got to know that previous character was same and now present character is also same. Was there any evidence before also when they were same? So for that particular thing, we require this count of character. And then at the last comes that how many elements still we can delete. Because in this question we are given with one more parameter and that is for deleting at each particular index so that we can get a minimum run length encoded version of S, right? So that's why here we are required with one more variable. Now comes the part means according to all this it will become a 4D right? Because here four variables are there. But today in this particular video, I'll let you know that how we can make this 4D solution into a 2D solution by just tweaking some of the things. So now before going ahead with the 4D to 1D or 2D, sorry, 1D, 2D solution, let us check that how basically this question is required to be done. Then only we can optimize with the same. So here, the recursive tree, which is about inclusion and exclusion only. So how the things will be going? So current string and the remaining string. So those two things we are taking here. So as it is about inclusion and exclusion, so first we are keeping and then we are deleting. These two things we can do. So that's why this recursive solution will become 2 raised to power n solution, where n simply refers to the number of basically length of the string. So now first we are taking this a, right? So our k would be as it is because we are taking as it is, we are not deleting anything. And if we are not taking it, so our k will become 1 because we are not taking it. So we'll do -1 from that k. Now, next. Now becomes a. So we are taking a. So that's why k remains as it is. But here, we have just taken that previous a till now and we have not added our new a. So we have basically removed that new a, right? So that's why k becomes 1. And here, blank characters were there. And so on, they were here. But here we have taken that in. That is the thing. But that one was as it is carried. But here we have not taken anything, so it becomes 0 at this point. But when it becomes 0, so we will check that does the S length is still there? Yes, it is there, right? Only the K is now equal to 0. So that's why here it will be returning sort of false. So this branch we won't be taking. Now comes the next part. When one more A comes. Now here we will be taking, but K remains as it is. Here we have removed, so from 2, now K becomes 1. So now here we are keeping it, right? So here we 1 becomes remains as it is, but A is again added. But here we were deleting. but this branch is also eliminated now. Now here at this point, we are carrying forwarding that previous A and that new A is also added, but one remains as it is. And this branch is now deleted. Now at this point, if there are 4A, we are taking our 4A, 2 as it is. Here we are not taking, so that's it. From 2 it becomes 1. Then from this particular A and 1, then from this A and 1, now we have carry forward same thing, but new A is being added. So we are adding A here. And in this particular scenario, now in this particular scenario, now we are not taking anything, so that's why it becomes 0 at this point. Now in this next scenario, we have carry forwarded that A and added that new A, so that's why it becomes A, comma 1, right? And here it becomes blank, so this particular is discarded. So like this only we will be going ahead with this particular tree. So it will be going till the end, means till this particular point. And at the end, we will be able to get that particular string, which after deletion, we got the minimum length. So like this is about the recursion of this particular. Now comes the part, because it is recursive solution. So I've just given you overview that how at the backend this would be working. But now the thing is that only this particular thing won't help us, because this will become about 2 raised to power, it will become 2 raised to power n solution, something like that. But from this, because it becomes such a solution, so that's why there would be TLE. But we can take lessons from this particular, and those lessons are that each level we are either keeping new character or deleting new character. That is the thing which we are doing, right? That we are required to do in a DB solution as well. Then, when keeping new character, then K remains unaffected and just checking for the S dot size. Because at this point you were checking, right? That we were checking S dot size. And when deleting new character, then K decreases. We keep check for K greater than 0 and also S dot size. So here we were checking for this thing, right? Now, about other two variables, that is the previous character and the count of the character, right? So for that, we are helping us to keep check on minimum length that could be achieved at each level. So these two characters, now I will explain you through the code that how we are required to keep a check for these characters. Basically, from this recursive, you got to know that how K and each index are being playing the role, right? From this particular dry run, means this particular example which I had given you. So from here, you got to know that how the repeating characters are being affected and how non-repeating characters are being affected. So from here, you got other point. Now let me show you that how we are required to code this solution. Basically, we will be either choosing it or not choosing it. So for that context only, we are required to code this solution. So now let us head over to the coding part of this question. So basically, as per the all things, here the time complexity will completely become n into k square. That would be the thing. I'll explain you how it becomes, and even the same goes for space complexity. But the space complexity, there would be some tweak as well. So let us explain you how it is. So now, this is starting of a solution. So we are taking DP. Here we are taking just 2D DP, and we will be handling that previous and count of those particular characters, not in a DP but externally. That I'll let you know that how we are handling. Now, here the 2D DP is there. So first will be about the index of the particular string, and the k plus 1 is for this particular k which is being given to us, that how many we can delete. This k plus 1 is basically for the thing that how many we can delete, and then we are initializing with minus 1 so that we can keep a check that is that particular is filled with some content. If it is, then we will returning that content. If not, then we will be going ahead and filling up this particular position. So that's the thing we are initializing with minus 1. So that's the thing here. Basically, we are memoizing our top-down solution. So that's the thing which we are doing in this question. I've not given you the recursive solution. I've just explained you recursive solution. And here we are directly at the end returning our whatever answer we will be getting from this particular. So here S simply refers to the string which is being there. K refers to the number of deletions which could be done, and 0 refers to the previous character which was being there. Now here let us go ahead. So here this is our solution. Basically DFS, because earlier we had done the recursion, and in that recursion we are basically now memorizing the same. So that's the thing. Now int k equal to capital K, we are at every moment of time checking that what exactly now k value is. Now we will be checking that if our s dot size, basically the size of the string which is being there, minus left. Left is basically the previous character which was being there. If that is basically less than or equal to k, so then we will be returning 0. And why we are returning 0, and what is the significance of this particular code of line of code? Yeah, line of code is that, see, that if at that particular point we are completely exhausted, means if we have directly now reached at the last point, or you can see at that point where now our k has become 0, means we can't delete any more, right? So that's why at the end now we are returning 0 at this particular point. So that's the thing. It is sort of, you can say directly it is the base condition for the key, that if all the key characters has been exhausted now, because it could be at any point. Because see, when we are having in this first example, you can see that here k was equals to 2, right? And the length of the s is basically more than k, right? And this will be usual in all the examples as well, right? So in that context only, this left would be the previous character only, right? And when we, this length, this would be something 3, 4, 5, 6, 7, 8, right? 8 minus, say, if our 8 minus, if we do 8 and then minus something like where it becomes exactly less than or equal to k. So at that moment, we will be returning 0, that we can't delete any more further. So that's why we are returning 0 at this particular point. Now at this point, we are simply checking that is our DP completely filled or not at that particular index. If it is greater than 0 or equal to 0, that simply means that our TP is filled now, right? So that's why we will be returning at that particular moment. Because earlier we had initialized our DP with -1. And if it is basically greater than or equal to 0, that simply means that it has something, right? So that's why we will be returning at this point. So this is what we are doing here. Now here, result. How we are required to calculate this? Basically, here, the thing is that if k exists, then at that point we will be checking, means we will be again calling our TFS, and how we will be calling. So here we are doing left plus 1, that is increasing our index, right? And k minus 1, that is deleting that particular. By increasing our index, we are moving ahead, right? And moving ahead, we are checking that because we moved ahead. So that's why we are not including that. This is that exclusion case, and thus we are basically here subtracting by 1. So that's the thing which we are doing here. So this is that scenario when we can delete one character, that is k exists. But if k doesn't exist, then we will be returning 1000. Now why we are returning 1000? Or this is not 1000, this is 10,000. We could have also returned int max also, or any particular number which is basically greater than 100. We could have returned because our string length is 100, so we can take any number greater than 100. So that's why, that's the thing. And now why we are taking that? We are taking because we require minimum length, and at max length till can go up to 100 or 101, something like that only it can go, not more than that. So that's why we are taking that 1000. So when we will be returning our minimum length, so it will by itself take the minimum out of this particular which we are returning, and the thing which would be there means the length which would be there. So that's why we are returning with 10,000. Now comes the next part, that c is equal to 1. So here, because uh not because, here simply we are starting with because now we have just deleted one character, right? So that's why we are starting with the count as 1, that we just deleted one. So there would be one character which is there, or you can say either that if that previous character exists, right? So it would be 1, or if that previous character doesn't exist, then again the new character which we are taking, that is also 1, right? So that's why we are taking this particular C as 1. So this is the thing. Now here, basically this question is all about, you can go ahead with the recursion, then backtracking, and over that it is about DP. So that's why that at any point, the thing which we are doing at this particular is, see, here these were the base cases which were required. Now comes the main part of this question, that is this particular portion. Now here, because of TFS only, we will be able to get at every moment of point a new character, from where we will be checking that now if we go ahead with this particular character to this particular character, then how many instances are there where we can figure out that it was now minimum. So that's the thing. Basically, what I want to say is, because of this function which is there, again and again DFS would be called, right? So because of that only, we will be able to figure out that at from what index we are required to start. Because of this only, we will be able to get new left values at this particular point. So that's the thing which I want to convey. Actually, about this question, I had already means the thing which now I'm explaining. This thing I've already explained in the question part sum. Here you can check out that how I've explained, because the thing was that there was something like that, because in that part sum 2, I guess, or part sum 3 means some question like that, there was a thing that we are required with the longest part sum, means a part sum which can go through root or which can't go through root, something like that was there in that question. So from in that question also I had used the similar trick, that if we want to include this or not include this, so according to that we will be running basically a DFS call earlier only, which will give us left value which we can use in this particular loop. So that's the thing which I'm using in this question as well. Now comes the next part. So now let me explain you this particular, how this goes on. So the thing is that at I is equal to left plus 1, we are starting from this and then going till the string length, because we can't go beyond that. Increasing means basically a simple loop I'm using here. Then here we are counting that minimum length which was being there. So how we are counting this? So now we are checking minimum of result, means the previous length which was there, and then we are checking what we are getting at this particular moment from the DFS. This plus 1 is for that character which will be there. See, because this A which is there, here A3 would be there, right? So if our present character is A, right? So how are encoded that what that name is? Encoded version of S, run length encoded version of S would be A3, right? So because of that only, here what we are doing is that 1 is for that character, that is for A, right? So now it was A3, right? So other character would be 3. So how we will be getting that? It will be because of this thing only. So if our C is basically greater than or equal to 100, so it will be 3. So we will be adding 1 plus 3. And what I'm explaining here is this thing. So if our A was this 100 is basically for the C. So if our C is basically greater than or equal to 100, so our that length will be, our result would be 4. How 4? 1 for this particular A and 3 for this particular 100. So here also 1 for this A and 2 for this 10. So that's why 3. So this is what I'm explaining here, that if our C is basically greater than 100, then we will be returning 3. Or if it is greater than or equal to 10, then we will be returning 2. Or if it is greater than 1, then we will be returning 1, else it would be 0. So here our result would be something like this. And that is how we will be returning the result. Now next thing is that if our index basically reaches the end of our string, then at that moment we will be breaking, because if we don't break at that point, then we surely will be getting runtime error. So that's why we will be breaking at that point. So now here we are checking if our that index and the left, which from where we were starting, right? Left here is acting as the previous. So if our that present index and if our left index, if they are equal, then we will be increasing our count. So that is the thing which we are doing here. Else we will be decreasing our k and we will be checking if it is less than 0, then we will be breaking. Because if our k doesn't exist now, so when our loop runs for the next index, so here at this particular point, we can't send our k, right? So that's why we are required to break that at this particular point only. So that's the thing which we will be doing here. So after exiting this particular loop, then we will be returning that whatever result was being there at that particular left index and at that particular what we say relations by k. So that's what we are doing here. And at the end, because this particular will be returning an integer only, right? So our return type is integer. So at this moment, we will be returning the minimum length which could be returned. So that is the thing which we are going to do in this particular question. Now comes the part about the time complexity and the space complexity. So basically, here you can see that here things are because of this particular DFS only, means two time DFS would be here. Is basically one time DFS here and one time DFS would be here. And here it is about the n time running of that particular loop, right? And this DFS is completely dependent upon this particular K only because it will break at this particular point, right? And here also DFS is completely dependent upon this K. So because of this thing only, here we can conclude that a time complexity. So here we can conclude that a time complexity will be completely equals to order of n into k into k. So that would be a time complexity. Now comes the part for the space complexity. So basically a space complexity would be, here you can see that we are just taking single space and that space is of this particular vector only, right? And that is also a 2D vector. And that can go up to n into k only, right? So that's why space complexity is n into k. Here you can directly see we are taking this s dot size and the other part is k plus 1, right? So which is basically n into k. So this was all for this particular question. Hope you like this explanation. And if you have any doubt about this explanation, you can comment that down or even you can join the live sessions which I usually do on Fridays at 10:30. So from there also you can clear your doubt if you are not able to clear that in the comment section. So that is also a thing because sometimes I feel like that there should be some doubt sessions as well, which in which you can clearly clear your doubts one on one in that session. So that's what I have started with. And yeah, if you like this lecture, then please do like and subscribe to my channel. And further also share among your friends so that my channel could get much more support and it will boost my confidence as well and motivate me to make more videos. So yeah, this was all for today and yeah, thank you.